Today I'll be discuss regarding of BWSSB paper. That BWSSB paper I'll be discuss that paper. You have two softs. See here I'll be write it in two softs. The question number is 11. Two softs. Two softs. One are solid. One are solid. And the other other hollow hollow are made of the same materials and are having and are having and are having and are having same length and weight, same length and weight, same length and weight, same length and weight. The hollow soft is compared to the solid soft. The hollow soft is compared with solid soft, solid soft, solid soft is. See here the question, two softs, one are solid and another one is hollow, made up of the same material, material is same. Suppose this is the aluminium, this is the also aluminium, this is also hollow soft, this is the solid soft. See, uh, same material and are having the same length and weight. The hollow soft is compared with the solid soft. The first one more strong, more strong, more strong. Second one less strong, less strong. Third one having same strength, having same strength, having a same strength, having a same stiffness, having same stiffness, having the same stiffness. See all of you here, two softs are solid, another one is hollow, made up of the same material. You are made up of the aluminium and aluminium. See, having a length and weight is the same. Hollow soft compared with the solid soft. Hollow soft is compared with the solid soft is more strong. Is more strong. That is the answer. See, hollow soft then the solid soft. You have a greater torsional strength. Okay. See, you have in one hollow cylinder, another one is solid cylinder. You have a filled. Always will be more strong. This is the technical concept. Always will be more strong. This is the 11th questions. Then I will move for the 10th questions. Then I will move for the 10th questions. Then will be 12th question. The 12th question for BWSSB is asking polar modulus of a soft, polar modulus, polar modulus of a soft, polar modulus of a soft section is equal to section is equal to see the polar modulus of a soft section is equal to see just I'll write it to the four answer. The first one A, product of polar moment of inertia, product of polar moment of inertia, polar moment of inertia and maximum radius of the shaft, The second one, ratio of polar moment of inertia, ratio of polar moment of inertia to maximum radius of shaft, radius of shaft. Third one, sum of polar moment of inertia, to maximum radius of the shaft, Fourth one, difference of polar moment of inertia, and maximum radius of shaft, Please look it here. Polar modulus of shaft section is equal. See, there are four answers there. The formula is, see, what is indicated the formula? Zp equals J by R. Zp means polar moment of inertia. J means polar modulus. Zp means polar modulus. J means polar moment of inertia. R means distance from the center to the outermost. See, J means 5d square by 5d to the power 4 by 32. R means d by 2. You know radius means R, d by 2. What is the formula here? Ratio of polar moment of inertia to maximum radius of shaft, J by R. J by R means pi d square, pi d to the power 4 by 4, 32, denominator by d by 2, that will be cross multiplication to 1 ja to 16, here d by 2, okay, then dd can cancel, remaining values pi d cube denominator by 16, okay. That is the answer for ZP. See, that is the answer is second one, that is calling about ratio of polar moment of inertia to maximum radius of shaft. Maximum radius of shaft means J by R. ZP is the modulus of polar modulus. This is the polar modulus of shaft section is equal to see, this is the Next I will be start the next questions. Next question I will be started. If di and do, if the 13th question, if di and do are the inner and outer diameter, are the inner and outer diameter, outer diameters of a hollow shaft, of a hollow shaft, then its polar moment of inertia, then its polar moment of inertia, polar moment of inertia. See, what is indicated the question here? Just look the questions. If dA and do have the inner diameter and outer diameter of hollow shaft, then is polar moment of inertia. You have in a hollow cylinder. What is the formula for hollow cylinder? Just you have one cylinder is there, that is in hollow, dO by di. 5 by 4 dO by di to the power of. See, just I write the polar moment of inertia. J equals 5 by, just I will be write the answers. A equals 5 by 32, 5 by 32 dO to the power of 4 minus di to the power of 4, the close bracket and close bracket. This is the question A. And question B, 5 by 32, 5 by 32 dO to the power of whole cube minus di to the power of whole cube, the close bracket and close the bracket. Third one, C, 5 by 32 dO to the whole square minus di whole square d 5 by 32 dO minus di. See, look it here. What is indication here? You have in a hollow cylinder. Suppose you have in a hollow cylinder, then that is calling about polar moment of inertia. That is calling about J. J is equal 5 by 32 dO to the power of 4 minus di to the power of 4. This is polar moment of inertia. This is the correct answer. 5 by 32 dO to the power of 4 minus di to the power of 4. Suppose for example, this is one cylinder. This is you have a hollow. This is you have in a hollow. See, this is outer diameter is dO. dO indicated the outer diameter to the power of 4 minus inner diameter to the power of 4, 5 by 32. This is the correct answer. This is the correct answer. Next I will move 14th questions. 14th questions. The 14th questions, a solid shaft transmit a torque, A solid shaft transmits the torque, transmits a torque, transmit a TORQE torque. T, the allowable shear stress, the allowable shear stress, the allowable shear stress is tau, allowable shear stress indicated by tau. The diameter of the shaft, the diameter of shaft, see here, a shaft transmits the torque T, the allowable shear stress tau, the diameter of the shaft, the first one 16T denominator by 5 tau into 3. Second one 32T denominator by 5 tau square root 3. Third one 64T denominator by 5 tau. The fourth one 16T denominator by tau square root 3. See, a solid shaft transmits a torque T, allowable shear stress. See, you have a solid shaft, you have a one solid shaft is there. What is meaning by torque? Twisting movement. Torque means you have a twisting movement. The twisting movement here, twisting movement, the allowable shear stress tau is diameter of the shaft. See, just I write the one diagram. T J by R. This is the answer is this one. 3 square root of 16T by pi by J. This I will be given the explanation. See, T by J equals J by R. J is equal to 5D to the power of 4 denominator by 32. R is equal to D by 2. You want to shear stress, I want to find out. This is see, the answer is tau is equal to 5 by 16 next D is equal to, next shear stress is equal to tau is equal to 16 into T denominator by 5 J allo. This is 1 by 3. This as it is written as tau equals square root of 3 16T denominator by 5 J allo. This is the answer. See, this is the cross multiplication answer. See, next time we go for next questions. This is the 14th questions. Next question I will go for. See, a solid shaft transmits the torque T. The allowable shear stress tau is diameter of the shaft 3 into 16T by 5 by K. Fifteenth one, the magnitude of the force, the magnitude of the force, magnitude of the force of friction, magnitude of the force of friction between two bodies, one laying above, the other depends upon, depends upon the roughness of the see, first one, upper body, second one, lower body, both the bodies, third one, both the bodies, body having no roughness, see, the magnitude of the force, friction between two bodies having above the, depends upon the roughness of the dash, upper body, lower body, both the bodies, body having roughness. See, force is equal to net force is equal to mass into acceleration. Net force is equal to mass into acceleration. You have to find out the acceleration, net force denominated by mass. See, for example, force is equal to 8, mass is equal to 2 kg, 4 meter per second square. This is the acceleration due to gravity. Then, to answer is both the bodies. Why? This is 4 kg, both the sides. See, the next question, the 16th question I written here only. The 16th question I am written here only. No, you don't. I have so much space. I need so much space. Better to have the repeat and start the explanation. 16th questions. The enthalpy and entropy chart in enthalpy and entropy chart. The superheated area lines. The superheated area lies dash the dry saturation line. Dash the dry saturation line. See, the first one, I just write it here in the diagram. See, this is the vertical line, this is the horizontal line. This vertical line will be indicated the P. This vertical line will be indicated, this is indicated H. This is the saturation curve. In enthalpy and entropy chart, sorry, this is HS diagram, not in pH diagram, this is in HS diagram. This in HS diagram, you have three regions. this is wet, wet plus dry. This is superheated. This is superheated. This is wet, wet plus dry. This is superheated. See here, this is the point. See, below the dry saturation line. The first answer is below the dry saturated line. Saturated line. Below the dry saturated line. Above the dry saturated line. Above the dry saturation line. Third one, on the dry saturation line, on the dry saturation line, on the dry saturation line. Fourth one, on the specific volume, on the specific volume, on the specific volume. See, look it here. In the answer is above the dry saturation line. Above the dry saturation line. See, wet, wet plus dry and superheated. See, in enthalpy and entropy chart, the superheated are lines dash inside dry saturation line. This is above the dry saturation line. This portion above the dry saturation line. This is called in entropy and enthalpy chart. Superheated are lines, dry saturated lines. Below the dry saturated lines, above the dry saturation line, on the dry saturation line, on the specific volume. My name is Dr. Rudresha. I am a professor from engineering college. Please, everyone, you have subscribed my channel and please share in your students. I will be preparation for the competitive exams. Please, everyone, start subscribe my channel and like and comments, and please everybody should be whatever doubt is there, please comments my channel and ask the questions, ask the queries, especially for mechanical engineering and other branches also in the general paper. Please ask and communicate with the all the my dear students. This is my sincere thanks for you. You have please my channel will be subscribe and you are motivated to more views.